Um, Can you okay. So I've not started the presentation. So let me explain what is scoop before starting the presentation. So till now we were saying that we were processing the data, but practically that data need to be moved into the cluster. So when data is required to be moved into the cluster, there are different ways how you will be moving into the cluster data. You would be moving into the cluster. But widely used is Scoop, which helps you to connect your RDBMS world, and you can get the data from your RDBMS world to the SGFS cluster, and vice versa also. You can export the process data from your SGFS world from the Hive tables to your RDBMS world. So Scoops helps you to input the data and export out the data from your SGFS clusters. And you would be using it widely for all your data which is lying in your systems to get in the data. There could be other things which you can also use, connectors for Cassandra connector, MongoDB connector, Scoop connector, Flume for the logs data. There are a lot of connectors to the SQL world. We are looking into one of them, that is Scoop, because you will be using it majorly to fetch your RDBMS, that is your relational data. But practically you might be using hot folders also, where where your other application might be pushing in the data, or you might be pulling in the data. So all of the connectors are a lot of, but we are looking into Scoop, which is widely used, and normally whenever you have to connect to any of the RDBMS world, you will be practically using a Scoop. So I am sharing my screen. So I don't have any PPT for this. I hope you can see mine. So, okay, 1 minute. So I hope you can see one of the file opened on my PC. So I don't have any PPT for Scoop. We have commands which are used to scoop in the data or scoop out the data. We'll be looking into those commands, and we'll see how Scoops helps you to get in the data into the SGBus cluster or get out the data from the SGBus cluster. So either what we can do is we can use any MySQL instance or any SQL instance which is installed somewhere else and then get in the data. But that would require a lot of effort. So for the easiness for this session, or for you to test out the things, what you can do is in the Hot VM which I have shared with you, MySQL is already installed over there. So we'll be using that MySQL instance installed in our VM to interact with that from the SGBus world. So, and normally the scoop command starts from the scoop, and the rest everything is the parameters which you pass to the scoop command. So Scoop is already installed on the cluster, on the VM image which I've shared with you, and we'll be using the we'll be looking into different Scoop options. The extensive list of options, we'll be looking into many of them, but practically not all of them is not possible. So we'll be looking at a lot of useful options which are available by Scoop to fetch in the data or fetch out the data, or basically export the data from the SGBus cluster. So as you can see, the first command on my screen is scoop list databases connect. Minus connect is a parameter which I am passing to this command, which is connecting to this URL of MySQL, and the username is root and the password is null in this case. But you can always set the password and send the password also over here by giving minus password. So let me show you the MySQL instance running on the VM, and then we'll use the scoop command to look into that MySQL instance. So I'm opening the Hortonworks VM and opening a Qt connection to it. Okay, so Omid, I hope you are able to follow me, right?
Yeah, I can see it. Yeah.
Okay. So let me connect to MySQL first and show you the cluster. MySQL -u. So there's a MySQL which I am connecting from there. So there's a MySQL instance running over here on this sandbox also. Let's say so. So these are the databases in it. So Hive use MySQL only for storing some of its metadata information, and that is what you can see over here. There is a database called Hive, which Hive is actually using. So all of these commands at the backend are using some of the things to store the things, like OC is using Derby database, MySQL is using Hive database. Scoop is also storing some of those things in the database for the job related configurations. So at the backend, lot of things are installed on this cluster, and these are used. So we are just using this MySQL instance for our testing paper or for this demo system. So let me duplicate the session and open another command prompt. Okay. Hey Vasha, good morning. Okay, so right. So let's use that command which I was showing you over there. And so what I'm doing is I'm connecting to this MySQL instance. You can use any of the connector. There are a lot of connectors available for Scoop. Most of the libraries are there itself in this cluster or are by default shipped with the Scoop. So for no, Basha, we can't hear you.
Let me try this.
Okay, so now what I'm saying is I'm connecting to that MySQL instance and giving the username and password. Right now there's no password set for this MySQL, so I'm not giving the password.
Hello?
Hey Basha, good morning.
Yeah, can you hear me? Can you hear me?
Yes, now I can hear you.
Okay. So I think some stupid setting got messed up here. Okay, that's good.
Okay, so so basically, great. MySQL unknown database. Okay, I gave the database name over here. I have to look at the databases, and DP was not there, so that is the error which I've got. So you can see it's shown you all the databases there in a MySQL instance, and this Scoop has connected to MySQL World. So now let me create a database over there, and let's use that database for our further on processing. And I will also create one or two tables in that, so that will be exporting or importing. So let me switch back to the MySQL. So now the database DP is there, and let's create a table. Let me first see tables in some of these things, and we'll use that only. So sure, use Hive tables. So there are a lot of tables. Let's use. Select start from partitions. There's nothing. From rows, division params, columns. Okay, there's a lot of things. Okay, we'll use this table. So use DP, create table, Pathshala as select star from hive dot. So I'm just creating a table right now in the MySQL instance, and which we'll be using up for import and other things. So select a star from. So these are the columns, and the table is created by the name of design Pathshala. So we'll use this to fetch in the data or fetch out the data, and we'll use this table. So this is a table which I have right now created, a copied from other database. So here let's look into another command. Here what I'm saying is this command, as this command listed all the databases after connecting to this instance. This command will list you all the tables after connecting to this instance. Here I'm defining which database to connect to, the database name which I've given DP, and this is the same database which I've created over there right now. So now it should show the table which I've created by the name of design Pathshala. So let's look into that. So it will connect to the MySQL instance, will fetch out all the table names and will print for us. So there's only one table which is printed for us. And now we are saying over here import table and saving the table name. So I have created another table. So let's use that table. So I'll just replace this thing to TSIGN, okay. So I have just replaced that thing. So what I'm saying over here is scoop import from this IP, from this MySQL instance connected to us with these credentials. Get a table by the name of design Pathshala and get the table inside this directory. The directory name is user DP, user udp scoop design Pathshala. So before that, let me delete this directory. The directory is directory will not be existing up. We have just given the table name. So let's see, and let's see if the data is getting copied at this directory from this table. So not to this, to this. So I said import, and scoop import basically is a command to import the data from the connecting database, and similarly scoop export also exists, which helps you to export the data to the connecting database. So here I am importing the data, and at the back end it will do all those things. It will create a MapReduce job for you to fetch in the data, and okay, so there is no primary key in the table, so it gave me an error. So in that table there was no primary key which was created for us, and it requires in that case split by. So I'll specify split by right now and will explain you what this error is. By the time, can anyone guess what is this error could be? Why it requires basically primary key? Okay. So if you can see, anyone want to guess what would be the reason? Okay, so if you can see over here, before selecting the data, it says select limit 1 from the table which I am importing up. So this select query basically makes make to the database to check what is the primary key and other things about the table. And why it requires a primary key over here is, see, it says the min and max of your primary key or the split table. So if the primary key is there, it finds out the min and max for the primary key, but the primary key is not defined for the table. It will find out the min and max of the split by column which I have defined. Now the thing is, this thing is used to divide your data, or divide your task into multiple mappers. So the data is imported with the help of mappers. So by this way, it will try to distribute your work to the different mappers. So over here, it will divide the database on the min and max tasks, min and max IDs, and will divide the data to the corresponding mappers, which will be importing up from the min to x, x to y, y to z, z to max. So here I've got another error, unknown column CD underscore ID in field list. Just a minute. Log on table IDs in field list. MySQL unknown column table IDs field list. The table is there, the column is there. What is the problem? Just a minute. So now I've just given minus M1, which will ensure that only one splits are created. But I'll just check what is the problem in the previous query. So looks like everyone is there now. Okay, so we got the data. I'll just explain what I was doing previously, what I'm doing now, and what is that error. So what I'm trying to do is I'm trying to import the data, and the data which Scoop imports up, it tries to parallelize the process. And how it tries to parallelize the process is, if you can see, it tries to figure out it tries to first communicate with the table, and then after getting the table parameters and other properties of the table, it tries to find out the min and max on your primary key. And the primary key is not defined. We can define the key on which we want to split our tasks. And based on those split tasks, there are a number of splits are created. Basically, number of mappers are created, and those mappers will be importing your data. So based on the min and max values, Scoop will automatically decide how many mappers are required, will create your mappers, or you can define your number of mappers. So how you can define a number of mappers which need to import the data? You can define by a parameter called m. So here I said m minus m equals to 1, so only one split was created. So in that case, it did not try to figure out what is the min and max. It just imported the data. But with the help of, when I was giving minus min, split by and importing the data, so let's import a new directory. It was giving the column not found. So let me just define the columns also, and that is minus column or columns. I just crossed. There is columns. Why this was giving an error? I'm just trying to figure out. So what I was saying is clear to everyone, or no, do anyone have any doubt? By the time it's running, I'm just testing this thing.
Hi Miraj, I have one question.
Yeah, go ahead.
Yeah, so in this the scoop import command, we know the table is created in MySQL database, and why do we need the target directory here?
Target directory is the directory where your data would be imported into SDFS. So there is a directory which is in the SDFS where your scoop would be importing the data. We are importing the data from somewhere outside.
Okay, and what will be the structure of the data under that design part?
Yeah, I'll just show you. I'm just opening that. Before that, I'm just wondering why the query first failing. So I just got a little bit involved in that thing. I'll just show you that data also in a minute.
Okay.
By the time it's running up, let me open the web UI and show you over there. So,
so you are importing the data from the HDFS to the RDBMS, right? Here, because
we are not importing. We are importing the data. So import is from somewhere outside to SDFS.
From MySQL database into HDFS.
So you can see your data is imported and all the columns are there. So we can define the delimiters and other things as a parameter over here, but right now it's imported as a comma separated file for you, all the data from the table. And next thing which I gave over here, okay, so there are the, now you can see, I'll just check why without minus column it was not working. I also want to work that also to work. But now you can see there are 4 files which are created based on the partition which Scoop has created on our data based on the min and max values of the IDS column which I gave. So half of the data would be here. So I just imported 3 columns. So here are only 3 columns. Half of the data would be here. Some of the data would be here. So now you can see the IDS column is divided across your files. The column which I gave. So this is how your basically splits up. Basically, they divide the task to different mappers, and each of that thing is created as a new file in your target directory.
Okay, so here basically you are splitting your database table that has like 20 columns.
No. I'm not splitting any my database table. What I'm doing is I'm splitting the import process. I'm parallelizing this import process rather than one thread getting the data from the table and storing it to SDFS. Why not 10 different threads run up and do the task in parallel? So that is what we are doing over here. We are splitting the data which need to be fetched. And that split data is divided to different parallel threads. Those parallel threads are nothing but the mappers which are running in your cluster, and those mappers are basically importing your data from a MySQL. So each mapper has created a file over here. You can see part M00 but not part R0000. So these are your mappers. There is no reducer over here. Only the mapper has done your task because it was just the import which you wanted to do, and those are the files which are created from individual mappers. Based on the min and max values which are fetched for the column which we have told Scoop to split the whole process. Basically parallelize the whole input process. Make sense? Make sense, Rajesh?
So each of these files, you said they are based on partition, based on the key that you provided in the split by, which is the min and max, right?
Which is not the min and max, which Scoop has figured out what is the min and max value, and based on that, it has just find out what is the best number of parallel threads which it should run to fetch basically import your data. So based on the min and max values divided across that, and the total data set, it has just thought 4 mappers would be sufficient enough. So it triggered 4 mappers and did the import for us. And in the previous command which I ran, which imported the data in this directory called design Pathshala, here I have said not to split. I have not used minus split, and there was no primary key in my file. So by default, Scoop tries to split your data based on the primary key, but in this table there is no primary key. So it gave me an error because it tries to split up. So what I did is I said number of mappers equals to 1 only. That is minus M1 if you remember. In this command I gave minus M1. So that says number of mappers should be 1. So here if the number of mappers are 1, the data has need not to be splitted while importing them. So practically there are no parallel mappers to be done up. So here you can see only one file which is created up and all the tasks are done by the single mapper. Make sense?
Yes.
Okay. And the third one which I was running previously, that should also run, but I'll lost that part and some time. So that way also it should have worked. But I'll cross it that part in some time. So this is the way you can, okay. So if I say minus P, it will prompt me for the password. If you don't want to give over here minus password or something like this. So it will prompt you for the password. Oh, sorry. It will use the password file also. We can give minus password file also, and it can read the password from the password file also. Only for security reasons if you don't want to put it in your script file. Now here you can see I am importing the data and importing it as a sequence file. So when I'm defining as sequence file, so in that case while Scoop is importing your data, it will convert your data format to the sequence file and will import the data into the directory. Now here you can also see one more extra parameter which is there with this command is management as append. So practically when your job runs up, if you can see, if I what is the error which you used to get in the when we ran the map reducer and other parts. So same error, see. If I say over here, it will give me an error, the directory already exists. So practically by default, it assumes not to overwrite your data. So there is an option, but practically scoop jobs will be running up daily and you might be getting an incremental data imported up into your cluster daily. So, so there is an option called append. So this append basically does not gives you an error and appends your data into the directory which you have defined over there. So even if the directory is existing, it will append the data to the directory. Otherwise, it would have given me an error if the directory already existing and existing over there. So normally, when you are importing your CDC chain data capture files from your databases or daily updates, so they will be using an option append also. So here I am not only appending the data to this directory, but I am also importing it as a sequence file. So it gave me an error, file already exists. And here now it will create me a sequence file rather than the normal text file which it has created previously. So now primary key again. To again give that option. So, rather than I should have created a table which has a primary key. Okay, but right now I'll just give that I'll give it an option. Or I'll give -F1. So I'm just saying one mapper. So by the time it's running up, let me create another table which has a primary key. Primary key is there. So I'll copy this whole command and create a table in my database. So I'll just copy it and give me a minute. Use TP. So I've given design Pathshala 2 as a table name and insert into this okay. So now the data is there. So I've just given the table so I've given the table script also. In this table script there's the primary key also. So we'll use this design Pathshala 2 rather than design Pathshala. By the time that would have ran, so you can see it has ran and the data would have been created in the directory. Let's look into the directory. So guys, when I'm changing the screens, does it change very fast for you, or by the time I speak, the screen is not displaying on your laptops? So I would be going slow in that case. I'm randomly changing the screen very fast.
Yeah, there is a lag. So you're talking about something that you did, but we get it only after a few seconds or few minutes.
Oh.
Yeah, only after when you change the screen.
Okay. So that because normally I present only on the PPT. So but now today I'm changing screens a lot. So okay, I'll go a little slower. So I just created one more table into the DP database in MySQL, which has a primary key. So I just given the create table syntax. So rather than creating a table as select star from table as another table, so in that case, the primary key is not created for you. So I have given the table create command specifically and imported some data into the new table. The table name is then Pathshala 2. So for other queries, we'll use the table. But for this query, we have given -m equals to 1. So there was only one parallel, one thread which is imported for us. And the data is imported into this directory sequence file. And you can see over here, but when I open this file, it's all sequence file. So I can't see anything over here. So the data is imported as sequence file. So this is how you would be creating up your different files also, or different file types. Here we can define the compression also and other things. I'll show you all those things in some time. So let's see. Now here I am creating an Avro file. So again, it will do the same thing. It will create an Avro file at this directory. Here I am giving the compress. So I am not only creating an Avro file, but I am also compressing the data. So I am importing it as an Avro file. I am also giving ---- compress. So in that case, the Avro file will be compressed for you by the default compression. So I'll just wait for a second.
The table name should be 2, right?
No, one table name.
Table name should be
one only. I created 2, yes. Yeah. So okay, it will give me an error, not a problem. So I change it over there only. Okay, so it gave me an error. So now you can see that it will do all the, not again, append display. So now say it again try to communicate to the table. Now although I have not given any split key, it will do the split on the primary key. Multi-column primary key, scoop will default to column ID for this job. Okay, so this table is a multi-column primary key. Okay, so okay, I just copied the table structure. I have not seen that as a multi-column primary key.
So
So it got it from the primary key, which is using for splitting up and doing all the tasks for us. It might create multiple wrappers for us to import the data.
Hey Miraj, so when you give ---- compress, what algorithm does it use by default?
By default is ZZzip, which is used across the cluster.
Okay.
But we can see other also. By the time it's importing up, let's see. So here I am saying -m, that is -m or -num of mappers. I think it's all same. So here I am saying it there was 10, so 10 different files will be created for us, and 10 different parallel processes which will be running up at the background. So -m and this thing is same. Here I am okay. So here, this is an interesting thing which I think you can, if you would be really working on the cluster and reporting the data daily, so these kind of problems you would be definitely facing up. So what happens up is now you are importing the data from your managed data which are managed by your Oracle or MySQL or MicroSQL kind of thing. And if there were nulls in the data, those were automatically managed by your corresponding Oracle or MySQL instances. But now you are importing the data to the file system. So when you are importing the data to the file system, your null could be either written as NULL or some other thing. So these things helps you to define your null strings and how they should be written into the file system, because in file system null cannot be null or something which could be read up as a null. So you have to define or you have to create your unique identifier by which you will be representing nulls. So if you talk about Hive, the default is /n, what I've highlighted right now in this command, that is treated as null by Hive. So that is what how we are importing the data. So what I'm saying is null strings are /n and null non-strings like integers or other things, they are also /n. So in that case, any null in the corresponding table which I am importing up would be converted to /n while writing to your file system, that is the SDFS file system. And double slash are over here. The first slash is escape character, second slash is real slash. So it will be /n only. First is just an escape character. So now here your nulls would be converted to /n, and while you are reading this data from Hive, the default null in the Hive configuration is also /n, although again you can change it in the Hive configuration parameters, which I've told you that is, which you can see by the set command, and you can set them also by the set command. So everything is configured, but by default is /n. So while you are importing the data, and if you are intended to use the data by the Hive, most probably if you are importing the relational data from these tables, you would be using Hive on top of that data. So you would be converting that to /n. Now in some scenarios you might have to import the whole database. So you can just import all tables. Now if you want just to exclude some of the tables which are of no use to you, you can say exclude these tables and export other things. Import other things. So this is how you can import the whole database at the one go or by a single command, or exclude some tables while importing the whole database. Now the major problem or the major challenge. Practically your data would be increasing up in your MySQL instances or your relational databases, and you have to import your data daily rather than so first you would be doing a one-time import, and after that you would be doing an incremental import daily or hourly or quarterly or bi-weekly kind of things. So in that case, you have to while you are importing the data, you will be definitely appending it to the target directory. But there are other things also, how you will remember what data you have fetched till now, or how you will tell Scoop also to fetch only that particular part of the data which has not yet been imported in the last Scoop import command. So this is what you would be using for that. So what I'm doing over here is null strings, I'm converting that to null. But after that I'm saying incremental append, and by minus incremental append, what I'm saying is it is an incremental command, and what need to be checked over here is the dim country ID, the column which need to be checked up, and the last value which I have fetched while importing this table. The here dim country ID is the primary key. So in my table, what is the primary key which I have created? So in my table which I have created, that is the problem. So there were two primary keys, and that's why it was given that. Okay, not a problem. Key columns constraint. So just give me a minute. Let me correct this table. That will make it more clear. So I'm just running this query so that the table is created with a single key. All the two keys will also not be creating a problem, but just cleaning it up. To make it little okay, this cannot be a primary key. Okay, that's the reason they have intelligently created that as a primary key. Okay, but some data would have been there. No, okay, only one row. Strange. Okay. So I'll just add one more row. Okay. And add one last more row. 3 rows will make sense. Okay. 4 rows are there. Fair enough. That is sufficient for us for this thing. So now say in the last query you have imported the data till in the first, if you can see in the first one we imported, okay, let's try to import this table and then we'll import add some more columns in this table. 18, 19 is there, yeah. So then we'll add the 19 column also there. So let's import this and then we'll use a sequential import. So if I import this table, what I have to do is scoop -1 is import and this table name, and that will import it. Now I know that my primary key is CID and the data which I imported is with the last key 18. So in that case, what I'll give over here is the last value is 18 and the primary key is CID. Or the check column. It's not mandatory for you to give the primary key only. Your other column might also be a unique key or anything which you think is an incremental other than this. So you can use that also. So I'm saying check this column and the last value which I imported is 18. So now get only the values which are greater than 18. So say I just say it rather than 18. Let's say it's 7. So it will only fetch me 2 rows right now while I import this, while I'll be importing this table. So it's importing up. Now similarly, you can also define your updated date column also. So rather than this, you can use your updated date column which says check this column, and you practically in your MySQL table there would be a column which would be updated date or created date kind of column. So you can define that column also here and just give that last time stamp which you have imported up. So in that case it will start importing the data which only for those rows where the updated date column is greater than what is defined over here. So now there is a primary key. What is the problem? I would be having that my country table also. I can create that also. Okay, let's use it for a time. So here you can see, if you see over here, see it now it has ran the query country ID or CD greater than 7 and less than 18 from this. So it, because I've given it over there, the last fetch was 7. So it's importing up, and it will just say the imported file will have only the columns which are greater than 7. Okay, so let it run. Now in this example, I'm doing the same thing which I was showing to right now. Here I have said last check column is last updated date time. So here incremental we had said append. Here we are saying last modified. So that is the difference between both of these commands. And here and the last value I am giving the date timestamp. So now here I am telling Scoop that I want to import the data which is inserted or updated only after this timestamp. Before that, I've already pulled it up. So now the thing is, who will remember what was imported last time, what was not imported, or till what ID I've imported, till what timestamp I have imported. No one has the time to remember those things, and no one has the bandwidth to write the code to remember this. So what Scoop gives to you is Scoop jobs. So you can create your Scoop jobs and define them what is your check column, and first time you can define what was the last value imported up. So this is how you can create a Scoop job, and later on all you have to do is just Scoop job minus execute. So it will execute only after what was the last value fetched, and it will after doing your job, it will update the job history or job parameters with the corresponding last value. So let me go back over there. Let's see the file is imported what we imported previously, and then we'll try to run this. So this is imported, and what was the directory which was imported? This is Pathshala code. Oh. So many files, to empty, to have some data. But the data would be, after what we have already fetched. So this is the previous command which I have run. I have not run this job command till now. The previous command which we have figured. So see here the ID 11 is there, and here probably the ID 18 would be there. So only two IDs are fetched up, and rest 6 and 7 are ignored for us when we did the increment. And similarly we can run the jobs. So just a second. Let me just correct this job with the corresponding column ID and other things, and the table name before triggering it. So what I'm saying is create job, giving a job name and the job details, that is import, connect to the database, use these credentials, table which need to be imported up, target directory where the table need to be placed up, and incremental append, check column CID, last value is 0. So first time it will import everything, and next time it will update the job parameters with the corresponding last value fetched, and that will be used up when we will trigger it next time. So right now,
if you don't give the target directory, what is the default directory it goes to for Scoop?
I doubt that is a mandatory probably, and that should give an error.
Okay.
But we can check it right now. But that should give an error practically.
Okay.
This should be a it should be a mandatory thing. Table. Yeah. No, it did not give an error. So in that case, it will import it to your user default directory. That is, Hugh is the user, so it will import it practically into the Hugh directory. So it should be a it's importing into the Hugh directory. So it will import to your user /Hugh. That is the directory where it will be putting up right now.
Okay.
So I'm just scaling it up, and that's the diagram shown. It will put if it's taking some default. But we can cross check it right now. It's importing up. And this job is created up, and now let's see the different parameters for the job. Right now, with this job is already created, we have not triggered the job, so there's no data which is imported to this directory design Pathshala 6. So that will be triggered up only when we'll be executing this job. So now this is running up. Let's let it run. So where it is placed. See, it's also given create a job rather than giving this incremental. It also gave a hint where it stored the data. Okay, let's see. What is the directory which we gave? Target directory. Okay, we did not give any target directory. So there's a table which has imported up. So if I look into the view, yeah. See. So my I is visible to you, right? So design Pathshala 2 is a directory created over here, and the data is imported over here. And this is the data which is imported right now. 9:33 is the time in my machine. And these are the files which are imported. So
Okay.
the default is the user directory.
Okay.
Okay, so let me search back to the. So this is how you'll be executing your job. So scoop job minus execute will basically execute your job. Right now, this job was not executed. So this job, I just created this job. So this is how you will be executing up, and this is how you will be listing all your jobs in your class, so which are defined. And this is how you will be showing that you will be looking at the different parameters of the job. So let's look into this job, and then we'll execute it, and then we'll again look into this job. So what I'm saying is scoop job minus show. I am just looking into the job which I've created right now in the previous command. So there is no password which were given for the job. So all that prompted for the password. So but there was no password for the job. Now you can see all the parameters related to the job were both false, incremental, last value which was fetched was 0. The database that it has to connect to, and number of things. So this is all things stored for you, and the target directory, everything, table exists, all those things. And when I execute this job, this thing would be changed to the last fetched value, and that will be used next time when I'll again execute it. If I say minus execute, that will be changed. Okay, and if I again say show, it will be changed to the corresponding 18. I think 18 is the max right now, so it will change. It will change to 18. Any questions on this job? These jobs, I think you will be creating up practically the jobs which would be importing your data daily rather than running the scoop jobs daily, or you would be creating Uzi workflows which would be doing import for you. So now, say you have to import the data from 2 tables. So in that case, you can say minus query and can give your full-fledged query what you want to import. So here I am giving a query where I am importing 2 data sets and giving some join condition, and it will be joined on that. And now if I am giving query, in that case again it does not know what is the primary key or what is your unique key on which it has to do the split. So again you have to define your split by column over here. So then okay, so sometimes these jobs which are created for you, if you look at them on the job browser. So if you look at them on the job browser, the names are some the name based on the table, or if you give the query, the name is not really good. So what I'm saying over here is, I am saying the job name which need to be given up. So this is the name which will be given to your job. So if you are looking at the job browser or tracking the job, it's little easier for you only for the debugging part. So you can give the job name by minus map produce job name. So this is a test job name which I'm giving to this this whole query, and in that case the job name everything over there would be your test job name. So I'm not running these things. Wherever you want me to run up or look into the data, do let me know. I'll show you all those things. But these are all pretty common, pretty very simple things. So I'm just giving you what is there, but not running them up. So now I hope you would have doubts if you want to change the terminator instead of comma and things like that. So this is how you can do field terminated by, lines terminated by, and you can change the comma to some other things which could be used by a hive or pick to import or do the processing. So this is how you can change your terminators from the default one. Now anyone has not asked me any question till now why I am importing it to the HDFS directory. Can I create a hive table directly from the scoop and give hive import? Yes, there is an option, and this is how, okay, after I'll cover this export after this. So you can say minus hive import and just give the table which need to be imported up. In this case, it should not only create your hive table by the name again of the design Pathshala, how this is looking into MySQL database, it will also import your data into that table. So this is how you can directly import the data from your MySQL or any RDMS Word directly to the Hive, and here you're not only the Hive metadata or the table would be created up, but the data will also be imported up. So it is doing two things for you, not only the data import into an HDFS directory, but also creating the metadata for the Hive. So in some cases you might have to map, the problem with when you are importing the data from different connectors or different RDMS Word, something which is represented as date time and something say that you have some timestamp column in Oracle, but Hive is not supporting say timestamp or something other than that. So there is a way you can change the column mapping also. So here I'm saying dim country ID, maybe it might be a big int in this host table, but I just wanted the int in my Hive table. So in that case, it will be created the int column in the Hive table. So this is how you can change the data types of the column while you are importing them. And now, if I want to partition data as well, not only to create the Hive import, but also want to partition the data. So you can say, other than Hive import, you can also say what's the partition key, and that data will be partitioned on that corresponding column. So I'm hard coding the partition value over here, but you can do the dynamic partitions also. You can directly import the data to the HBase tables also. And similarly, you can export the data by giving export. So here I'm giving export, and from which directory I have to export the data. And now while exporting, I have to define everything. If my data is terminated by comma or /n, and where to export. So in this database, it needs to be exported up, and to this table, it needs to be exported up. So export is again totally inverse of your import. It's very simple. All you have to give is some parameters, and there's a wide to extensive list of parameters, and I'll bring you the scoop page.
So, quick question. So, when you export it, the table automatically gets created, or you have to create it before you export?
The export, scoop is only for eligible words. So when you're exporting it, I'm given the table to which it need to be exported to the corresponding RDBMS word.
So the table has to be existing.
Yes. There it won't be creating. For Hive it would create it, but in that database it does not have the rights to create a table. And then the user might be having rights, but practically Scoop will not be creating a point. There might be an option to create also that everything is possible in this word, but I doubt there would be. So this is a page where everything extensive is written for you. Scoop guide. So this is all the commands that are supported by Scoop and corresponding parameters. We have looked into the import, export. These are the major things: the Scoop import all, Scoop export, jobs, Hive tables, list databases, list all list tables, Scoop help, Scoop version, just a version, and some compatibility things. So I've given you a glimpse of everything, but what is there? Not everything, but most of the things. And export might be creating a table, but I doubt it would be creating a table. Table driver, password, verbose, connect driver. No. So driver, if you have to connect to some other databases for where you have to define the drivers, you can also define the drivers. Otherwise, the default drivers or default drivers example are there in your Scoop lib directory. That is user lib Scoop. There is no such option I can see. Table is created. Table has to be there. Any question on the Scoop? Anything which you want to ask before we move on to the other topic? So there are a lot of parameters. You can just use those parameters. They can't cover all. Verbose basically prints a detailed summary for you. Driver class, you can define your corresponding class if you want. If you want to override the current class, if you have done some changes in the class. Partitions we have just seen, Hive columns we have seen, Hive drop import elements. What is this? From string fields and importing the data. Okay, so drop this particular things. So there are a lot of things. Create Hive table, Hive override will override your current data. So there are a lot of options. You can just browse them. But basically, the major commands are Scoop, export, and import, and there are a lot of parameters to import and export in different fashions. Any questions on this word before I move on to the other thing? So this is your Scoop guide. I'll share the file which I was showing to you right now also. All the commands which are there. The minus compression codec, you can define your own codec if you want to use bzip or anything. So there we have not defined while we define the compression thing, but you can define that minus compression codec and the corresponding compression codec so that your data is compressed in the corresponding format. So, okay, I'll assume no from everyone, no one has any questions. So let's move on to the Uzi part. So I'll show you the easier way of the Uzi, and then we'll show you the code part also. If you want, I can show you the XML part and how to run that. So Uzi is basically a workflow engine which helps you to create workflows which you can trigger up or schedule the things which could be running in your cluster daily. So say your daily you have to import some data with the help of Scoop, then you have to do some filtering of the data with the help of Pig, and then you are getting other data with the help of Flume into your cluster. You are merging those two data sets, and you are then getting third data from your Splunk into some other directory, and you're getting a 4 data from Internet of Things, and you're merging all these data together. Firstly with the help of pig, and then with the filtering, then you're creating some hive tables on top of that, and doing some hive processing on top of that, and doing some summarization, and then you are displaying those summarization to your business users. So practically when you're importing all those things, importing the data, running up n number of pig jobs, hive jobs daily, this practically it's not possible for you to do all those things manually, and handle everything each day. So with the help of Uzi, you can create your workflows. And workflow is nothing but you can stitch in different things which you want to do, and this workflow could be submitted up, and you can also schedule them, and those will be triggered up at the corresponding schedule frequency. So let's look into the workflow. So if you look into your PC, these are the default ones which are already there for you. So let's say I want to run my pig job. So these are some default ones which are already there on your PC, but I'll show you how to change them, drive them, other things. So it's pretty easy. So right now this workflow is not doing anything, but just triggering this pig command. So if you look into this, edit it. I'll give okay, before that, let me cancel it. Before that, let me show you a few more. So let's try to create a new one, then I'll show you these things. Create. Okay. So let's give some workflow names. So let's say test workflow, description, running 10 tasks for my, or let's say running my complete job. Now, this is a start tag, end tag. In between, I can do anything. So let's say first I want to import the data. So I'll say I have to run the scoop job first. So I just drag the scoop over here. It will ask me what are the different parameters which I have to run. So I gave it name scoop underscore import, description, for me, the command. So let's say let me give the scoop import command, some scoop import command. So this is a scoop import command which is to trigger. And if I have to say prepare before, so prepare is basically you delete, if you want to delete some directory or add some directory before running this scoop import command. So basically preparing a command, any parameters if you want to pass to this. So those things you can parameterize the things by something like this, $, parameter. So in that case, this parameter which would be passed from here would be replaced by this. And you can give other XML files, archives, if your job is to access them, other files if your job is accessing them, and just say done. So your scoop job is there. Now after a scoop, I want to do pig filtering. I just say pig. So
if you have more than one parameter to give,
yeah, you can give a number of parameters.
Just name it as parameter 1, parameter 2, or
no, practically you will not be naming as parameter 1.
No, in the scoop.
Yeah, practically you will not be importing naming as parameter 1. Practically, parameter database name, parameter table name, or everything would be parameterized for you, right? You will not be hard coding like the way I hard coded over here. Practically, you will not be hard coding it. You will be doing something like this. Target directory. So your target directory would be something like this. $base dir slash $.
Dollar should be outside, right?
Yeah, dollar should be outside. Yes. $, import dir, and practically your These things would be again parameterized, dollar, IP, everything. So practically you will be passing these parameters to your Uzi job, and those parameters will be automatically available for you over here.
No, but my question was, you don't name the parameter when you give it. It's just that first argument goes to the first parameter, whatever. Is that how it is? Can you give a name to the argument? That's what I'm asking.
Yeah. This is argument. Oh, okay. So sorry. This is not parameter. This is an argument. So okay. So these are the arguments. If I want to give to this scoop command something like this, some argument which when we run the command. So if you can see, this is the argument which I can give to this. So this is the argument which I give to the scoop command. So these are arguments. So this is not the parameter.
Okay.
Sorry. So this is the argument which you can give to the command while it's running up.
Then how do you pass the parameter?
Parameter I'll just show you. 1 minute.
Okay.
I'll pass it. I'll just show you. So parameters. So you can see I have defined 2 parameters over there, and while running it up, we can define our parameter file. I'll show you that thing. But also when I submit this, it will ask me for the parameter. This page. Oh, it is triggered. Where's my workflow? I have not saved it. Okay, not a problem. Okay, so after a scoop, I want to run the page job. I'll just show you how to pass the parameters. Just give me a minute. That was the argument. Parameters are also there. So these are the parameters. From the UI, how to give it, just a minute. Yeah, here it is, job properties, property name and the value. So okay, so say there are 2 things. One thing is just a minute, let's create some pig script which we'll be using over here, and options. Share comment. Oh, 1 minute, my screen got. No. Everyone can see my screen, right?
Yes, we see the edit node screen. Is it what you are showing?
Yeah. So this is a pig one which I was adding up. So there are 2 kind of parameters. I will just talk about that thing in a minute. Let me explain over here. So let's say this pig underscore filter which I'm creating up. So which will be filtering up my things and the script name. So this is a pig script which I'll be pointing it over here. So where my pig script is there, I'll just point it to that thing. So right now the pig script is not there. So but say let my pig script would be looking something like this. So say loaded is equals to load, then some directory from where it has to load the data. So $input input, and as then some names and all those things, say user and comma something. Okay, and then filtered is equals to filter loaded by user not equals to test. Again, something like this. So here my pig script is parameterized with the $input. Okay. So this $input need to be passed by pig script while it is running out. So this is the first level parameter which I was talking over there, and this would be passed from here. So this property name, I'll say input and the corresponding value. And how this value would be coming up, from where it will be coming up, I'll talk about that. So this is coming, say, input underscore dir. So this thing would be passed on to this job from Uzi, and this is a parameter which I'll be defining in the Uzi, which is defined over here on the right hand side. And this input parameter would be available to the pig script. And these are the arguments which you can pass. So I told some, and that is what I told you wrong. So argument is a different thing, and the parameter, the job properties are your basically property pair values which you can pass up. And how this Uzi parameter will be passed up, I'll just talk about that thing. And okay, this script name is mandatory. So let me give some script. Is there some? Okay, I'll give anything. And then I have to do some scoop export or hive, so I can basically create a whole workflow one by one, one after one after one. And then you have to over here you will pass your input input underscore dir and the corresponding value /users /live/db/ whatsoever directory and so on, and you will trigger the job. So I'm passing this parameter which will pass on to the pig while pig is running it up, and pig will take the pig, my pig is parameterized, and that will be triggered up, and your job will run. Another way, practically you will not be using this UI, although this is beautiful to run up, but when you are creating your big jobs, you will not be using this UI, you will be doing everything on the command prompt. So let me show you on the command. From here now you can submit these jobs and you can schedule them also. So to submit it, just say submit, and input directory is the one it has again asked me over here before submitting up if I want to change it, and if I say submit, it will submit the job, although right now it will fail. It does not contain any pig script, so it will fail right now, but this is how it will trigger up. So it will fail in a minute or so. So that is scoop one ran, but this will definitely fail. So now you can create, basically, so there are examples for each of those things. You can create your, you can run some SSH commands, you can run some scoop command. So all these different kind of job types are supported. Scoop, hive, pig, Java, MapReduce, some generic things, FS, Hadoop FS commands, email. If you want to email to some group after a job has done or some errors there. You can create your sub workflows also, so you can import a workflow in another workflow with type of sub workflows. So let me show you what happens at the back end. That will give you more idea. So at the back end, what happens up is there are files created something like this. Just give me a minute. Let me open the file. Can you see my screen again?
Yes, we can see.
Okay. So at the backend, what happens is this kind of XML is created for you, and this XML is what is created from when I created a workflow by the help of drag over there. So these kind of XML is created for you, and XML contains corresponding actions. So these are the actions which are created for you at the back end. So the start says from where this workflow need to be started up. So the start action is Hive. So this is a Hive start action. So this is what will be triggered first. And if this is okay, it will go to add. I could have added another action over here, something like this. So when I drag something else, these kind of actions are basically added. So say after Hive, I want to say take import. So what I'll say is pig import, and after Hive, okay to pig import. On error, kill. On error, I can revert the email, and I can create another action named email, and that will be emailing up practically, and okay to end, and error to kill. So and pig is okay to end and error to kill, error to email. So this is how your workflow is created up. After Hive, pig will be triggered. If there's some error, that email will be triggered up, and after email, your program will end. And in the email, you might be sending your error message and other things like that. So practically at the back end, these kind of XMLs are created, and each of these things have their corresponding action tags. So if you want to look at the detailed action tags, all of these workflows are there for you. I'll just show you where are the line, and you can get all the corresponding action tags from there. So all of these workflows are there in the user Hue Oozie workspaces, managed, and for all of them. So the corresponding these contain only the script with XML file. With XML file. There's no XML file. Okay, I'll show you a PPT which contains all of these actions. So basically these action tags you can create up, or these action tags are also visible when you trigger the job. So if I so if you want to see any of the action tags of what is happening, workflow, say I am running this Hive. So this would be triggering some Hive.xml which is lying at the backend for me. So let's try to trigger this. Save. Oh sorry, I don't want to save it, I want to trigger it. Submit, and submit the job. So if you submit the job, you can see over here the workflow XML which is created for you for the job. So this is a workflow XML which contains a Hive action. There was only one thing, so this is the action which was triggered. And here you can see the detailed logs of our jobs, the configuration parameters which are passed for a job. If I have added some other configuration parameters, those will also be available for me. These are the default ones which are sent: job trigger location, your name node, your Oozie lib path, and your workflow application XML which is at this location. User Oozie deployments. Okay, deployments. User
you have to speak slow because refresh is becoming very slow.
Okay.
And then you're talking, you're going way ahead.
Okay. So I was showing you that Oozie thing which you have triggered right now. If you open it, you can see the job definition over here. Inside this is your XML which is triggered up. This is the XML of your whole workflow. If there would have been more than one actions, those action tags would be visible over here. These XMLs contain other syntaxes also. I'll share you all the action tags which are supported by Oozie. But this is how they would be looking up. Or if you want to look at what are already created for you in the Oozie, you can just submit the job and you can see it over here. But these are stored in the file system also. I'll just find out where are they stored. So this is succeeded. You can look at the logs over here. This will tell you all the detailed logs about the Oozie. While you are running Oozie, I am 101% sure you might be facing a lot of challenges while running your first job. So these logs would be really useful for you. These are the configuration parameters which are passed while your job has ran up. So I'll also show you when you're running it from the command prompt how you'll be passing up all these configuration parameters plus the parameters which we have customized in our jobs. These are details. So this is the application path which I was trying to open up. These are the actions. So there were only one action, so only one action is visible. If there have been more than one actions, hive and then pig and scoop and all those would have been visible up and their corresponding status. So let's look at this location. There might be user UZ deployment. There might be other XMLs also lying up. So UZ deployments. Okay. So whenever I submit those will be there, but if I do not submit, those will not be visible. I have not submitted the other one over there, so only one is there. So I'll show on the command prompt also. Before that, I forgot to tell you or show you one thing. Let me show you that also. So in the workflow, right now we are doing everything sequentially. After pig we are running hive, after hive we are running something else. So let's say after pig I am running hive and hive process. I'll just select any random file over here and I just hit done. Now this is what I was doing previously. Everything sequentially after pig, hive and those things. But we can, fork the jobs also. I hope my screen is visible to everyone before I show you the fork thing. On top there is a pig filter and after that there is a hive process.
Yes, I can see your screen.
So we can fork the things also. That is the two things are running parallelly. So here you can see I have dragged them to parallel. So here pig and hive will be running up parallel and this is the fork which is created up. And the next process, if there is anything after them, say there is some Java job which is running after them. So Java, some Java jars, that's I'm just putting this, some Javas. So this Java would only be triggered once these two are completed up. So this is how we can do a parallel processing also while we are creating a workflow. So say we have to do imports from 10 different places, rather than importing one by one sequentially, I can add them all parallelly, and then after all the imports are done, I can then start my filtering process from the pig, or I can start my hive process to create tables when all the data is imported. So this is how you can create the parallel process also, and this fork is another parameter as an action which is added on top of the action tag. So if I submit this, we can look at the workflow also. So see, it again asks me for the input dir, but this is also everything is configurable. So if you look at the definition over here, I hope everyone can see the definition opened in the Uzi browser. Can everyone see?
Yes, I can see.
Okay. So today everyone is very quiet. I think either I am going very fast or actually these things, you have to just try it yourself, but I can just give you what is there. So you can see over here there is a fork which is created for you, and this fork says pig and hive, and the end of these things would be join. So the join which is created over here, and so these would be joining at this location, and this join would be going to Java. So this is how you can create your forks, also the parallel processing in the workflow. So this job will again fail in some time because there is no jar and all those things. So let me show you how you run on the from the command prompt. Okay. Before that, let me show you the coordinators also. So coordinators are there to coordinate or you schedule your jobs. So let's look into this. I have to give some coordinator name, some description what that coordinator is doing. Now here I have from the drop down I can select the corresponding workflow which I want to coordinate up. So the workflow which I have created in the workflow tab would be visible in this drop down. If the test one which I have created right now would also be there. So I can just select the workflow which I want to coordinate up. It's shared. Yes. So let me leave it to the ping only. That was running up. So and over here now I can set the frequency how it need to run. So a frequency of 1, the unit, days, hours, minutes. So say it need to run at 1, 9 minutes or some. So what is the frequency it need to run after every 1 minute or after every 1 day? The start time, what time it need to start? What is the end time? And this time is given is which time zone. So this is a time zone in which this time is given. And then if there are any input parameters to that flow, data sheet. Is fair enough. What is this data set? Okay, so now data set also we have to create. So these are the different data sets.
I'm not clear on the coordinators. Can you say it again? Because workflow, I know that it's setting up all the process, and we provide the data along with the pig and hive and things like that. So what is this coordinator again? Like, can you say again?
So your workflow which you have created up, again you will not be triggering your workflow manually each day. So you can schedule these workflows with the help of coordinators. So you will create a coordinator on top of your workflow XML which will be coordinating up your workflow, basically triggering your workflow at the predefined frequency. So here what I was doing over here, so let me create it again, 1 minute. So here what I say, create a new coordinator. I gave it some name, daily job. Description, it will trigger my test workflow daily, and from the workflow drop down I select that workflow which I have created up. Next, now I have to find the frequency 1 each day. I need this job to be started from tomorrow at every day 10 in the morning at the time zone of EST, and it should run for next say 10 years or say 1 year. So after 1 year it should stop, and then the continue data set, I will just add some data set and currently define output. We can define input directory. So data set I'll just define, and after defining the data sets you can just save the coordinator, and then in that case your workflow would be triggered at that corresponding frequency which I have defined over here. And data sets are the data set which will be passing up to your coordinators. So you can create your data sets over here. So this is how you would be reading up your daily data. So you can define the data set something like this. So basically, you know what data set is adding extra beauty to your workflow is. So when your workflow is running up daily, your input path would be changing up daily. You know, your data which you are importing for a scoop, you would be adding it to a partition by that day name. So each day while you're importing your data, you would be creating a new directory, something like this, for the corresponding day. So this is how your data sets makes useful your life easy. You can create your data set. So in that case, this workflow which is triggered today would be triggering on corresponding to the data sets. So now say I am importing this data to this corresponding directory from the scoop. So so my day would be automatically passed based on the today's date, and that is what you would be used up while reading your directory. So inside data, there is a directory which I want to from where I want to read up, or from where I want to put my scoop data, things like that. Does that make sense, coordinator? What that is doing?
Yeah, it does. Thank you.
Let me run it from there, the command prompt. Although we always run from the command prompt only. And there are big jobs which are running in our cluster. So let me. Yeah. So give me a minute. Let me put some data into SDFS, which will be triggering up. So let me show you the XML part, what we are doing over there. Then let's try to run it right now in the class. So this is an XML part, simple workflow where there is only one action, that is the Hive action. And here I am saying I am passing a job tracker node, and this is parameterized. So this will be passed up while I am triggering this UG job as a parameter. The name node is again parameterized. So this name node parameter will again passing up when we are triggering the job. The skip directory I can change any number of times. So I have parameterized the skip directory in this job. And this hive.xql is lying at this location, which will be inside my script directory. Again, that is parameterized. So all these parameters I will be passing up while I am triggering this job. And hive.script URL is again parameterized over here. So whenever for any other action, this thing is not required, but only for the hive this thing is required. And why this is required is because when Uzi is talking to hive, it has to know where the hive metastore is to communicate, or to check your hive tables and things like that. So hive-script URI is basically used to communicate to a hive server from Uzi, and this is what is required by Uzi when you are triggering your hive actions. But for other things, it's not required. So let's look at the hive file which you are triggering up. So let me open that. So hive side I'll just show you in a minute. So hive.sql, I am not doing anything great. I am saying drop actions table stocks underscore Uzi and create new table stocks underscore Uzi where select star from this table source. So I have some action which need to be triggered up in the hive.sql, which is referred from here. So this hive file will be triggered up by this workflow. And over here you can see I am passing hive site.xml also. This is a configuration parameter for my hive job to trigger up. So this hive site.xml contains different things which are used to parameterize your hive, and things like if the security is enabled on hive, if you want to do a compression on hive. So I have right now commented this thing. But if I want my hive jobs to compress, so all the hive related parameters are defined in this file. So these parameters will be passed on to your hive console while your hive console is triggered from the Uzi. So this file will help you to parameterize or set the different hive related parameters for you. So this workflow will be triggering up this hive.xml SQL file, and this hive.site.xml is the configuration related things or parameters which are required for Hive, and this is a Hive server URL. So these things I'm passing to this workflow XML. Let's try to trigger it up. Before that, we have to put all of these things into our SDFS word. So let me put these things into SDFS. So user UTP. Okay, let me create a new directory UZ. Is this the name only given over there? Just a minute. Submit, and inside UZ I have scripts. Inside that workflows. Workflow, and inside workflow I have all those files, so I'll import those files. So I have the workflow, I have set.xml, and inside scripts there is one more directory, Hive. So I'm just defining the same hierarchy because all the configuration parameters in the XML file and all those things will have to change. So rather than use the same thing. Okay, so now I have to trigger it. So for triggering, I need just one more file. So this is a file which I'll be passing to the UZ command that contains all my parameters which will pass on to UZ, and then UZ will be passing into the corresponding actions. So if you remember on the UI, I gave this parameter on the top level, and these parameters were also given inside the scripts also. So inside the script, those parameters will be passed on from the UZ, but before that we have to pass these parameters if those need to be passed to the UZ. So this is a file which I'll be passing on to the UZ, which is a file which contains all my parameters which I can pass to UZ. So this job.properties properties I'll create it locally from where I'm triggering UZ. So now let's say in this scoop, sorry, I'm switching the context too fast, but when you create those scoop, when you run those scoop jobs, so you can see the Java files are created for you. So this file contains all your code which is written at the back end, and which triggered your map rules and everything, which your scoop job has run. So sorry, I switched the context, but I just saw it, so I wanted to tell you. So this is a whole big Java file which is created at the back end to do all that import for you, which is there in the directory where you will. So whichever directory you will trigger your scoop job, that .java file will be created for you, and that .java file will have everything which is triggered for you, which is scoop will run for you. cd dot ls. So I'll just say so I've given the Hive URL, UZ lib path, so the workflow XML where my workflow is lying, so that is lying at $script directory, and the workflows and the Hive workflow.xml. This $script directory is defined over here, the base directory and the scripts, and the base directory is my name node and the user UBP UZ. So this is how your parameters work up one by one, and the name node is defined over here as JFS sandbox also. And I say okay, and I'll create one more file over here which is to trigger Uzi, which will be useful for us, but we can use this file command directly also. So let's see. Oh shit. So let's use it directly. So okay, it triggered up. Sorry. So what I'm saying here is Uzi job and minus Uzi, and this is the Uzi server URL which always need to be given up for any Uzi job. And then this is a config file which I passed it to this the job properties which I've right now created up, and the Uzi workflow path is there in the job property, so I don't have to give it. But in this command, this is given again. So I'm not sure whether this is the correct path which is given with this Uzi scripts workflows. Yeah, it is. Now I have to check the status of the parameter, or I can either go to the Uzi console which I was showing you over there, and I can either look it in the job browser. I can look it either over here. So that is killed. There's the right one. No, this is the older one. So is this submitted? Okay, this did not submit it up. Not a problem. So minus run. I gave directly running it up, and this workflow XML is already there in my job properties. So this now job is submitted and I got the job ID. So now this job would be visible to me. See, this is the job which is submitted right now. If I want to look all the properties from here on the command prompt, I can say minus -info, the job ID, and it will give me the information about the job. It's running up right now, it's still running up. If I want to look at the logs directly over here, minus log and the log for the job. Or I can look it over there here on the UUI, and this is killed. Let's see why it's killed. Or I can see logs over here also. So org Hadoop hive conf not found. Launchers. Hive-conf command not okay, because I have not uploaded the link. Okay, so over here you can see I am also passing some lib directory, and here all the libs are there which are required to communicate to each other, or we can point it to the Uzi lib directory, or we can upload all our directories. So Uzi also have a lib directory that is /user/lib/Uzi lscd. So it has most of the jars, but some of the jars might not be there. So what I normally do is I have my own extensive libs and I upload that to SDFL and use that. So we'll use that only what we have defined over here. That is the base directory /lib. That is base directory is nothing but users u. So I'll create this directory inside that location and we'll upload the jars. I'll share these jars also with you. And I'll upload all the jars. So it contains all the extensive lists of jars which might be useful for different communication connectors for MapReduce, Big, Hive, and number of 6. Although some of them are there in the Uzi lib, either we can point it to that, but I use it. I upload all the jars. So MySQL connector, all the things would be there, which you can think of, or which I've used till now in different examples. Okay, so all the jars are there. User hue Uzi lib, and that is what I've defined over here. Now let's again trigger it. CD slash. So I'm again running it up, and let's run it. So now if I have to again look at the logs or status, info, and job ID. So it's running up. So this is another way to trigger it up. So when you are doing the real development, you will be doing it from this black console only. But for small jobs, you can create on that UI. But the big jobs, you will be creating your workflows and things like that. And when you are creating your workflows manually, it's definite that you might be doing some errors in your workflow XML or at other places. So there is an option called -dry run. So this will just do a dry run of your XML. It will not trigger anything, and this way you can validate or cross validate whether your workflow is right or wrong. So there are different parameters. You can see them over here. So see, these are the different things. Info, resume. You can pause a job. You can resume them afterwards. Dry run, I just told you. You can so right now we have ran a job. You can submit a job, and then after that start it. So there is a submit, and after that you can start it. Other than that, you can just say directly run. So in that case, it will do a submit as well as a start. And these are the things for coordinator. So that is still running up. Error again failed. Let's look at the error. So that's why I was saying, when you are running your Uzi the first time on any machine, you will always get an errors and errors. What is the job ID? What was the job ID? Hive conf is still not found. Hive conf. So previous SDFS directory was deleted, and I have not corrected everything after that. User hue DP Uzi. I have created a wrong position. DP Uzi lib. User hue DP Uzi lib. User hue DP Uzi workflows. DP Uzi scripts and inside scripts workflows. Okay. So this should run this time probably. So by the time it's running up, there's another UI directly from the Uzi. Right now we are looking at the Hue UI, but there's directly a UI from the Uzi, and you can also look at your jobs which are running up on the Uzi UI other than the Hue UI. So this is Uzi normally runs on, the default port is 11000. So this is the port on which Uzi runs up, and the jobs which you have submitted would be visible over here. This is right now which is running up. If I double click, it will tell me what is the current status of the jobs and the details of the job and the job definition. So that again same XML which is submitted over here. But there's a beautiful thing which it also gives you is this UI which tells you your whole workflow, basically picturize your whole workflow, and the log which I was looking over there, and the configuration parameter which are passed to my job. So all those parameters which I passed from there are visible over there. So this is another way from where you can look at the UV jobs, workflow jobs, coordinator jobs, settings, everything would be visible over there. So let me look at the status of this info. It should have ran by now. Oh, again error, great. No, what is the error? Whatever. Command prediction does not hold before execution. Let me look at the detailed error. There might be something extra. So these are the jars loaded which I have defined over there. Everything is loaded. Okay, so here there are drop table if exists of Uzi. dp.stocks Uzi table not found. Okay, this table is not there. So the hive script which was pointing to some table, that table is not there. So that table need to be created up. That's the reason it's failed now. So once I create the table again, run it, it will trigger. So this is how you would be debugging up also, because when you are running your whole workflow, you will be getting a lot of errors, and either you can look at the error minus logs over there, but that might not give you the detailed logs. So you can look over here on the UUI, which gives you all the detailed logs of what was done, or you can look at the logs over here also. This will give you also the logs. Now this is killed and the job log. So here, but those details will not be there. But what kind of details you can see on the UUI. So that is minus log option only, which I was showing on the console. So I am not sure today. Everyone was too quiet. Whether I was going too fast, or it was too obvious, or it was too hard to get the things. Not sure. I did not heard any questions also. So is it going okay, or how are the things going? I know it's a lot of things which I've dumped right now in the last 1.5 to 2.5 hours, but these things I can only show you, because all of these things are related to configuration, XMLs, creating things. So there's nothing which is a flow kind of thing which can show you of the things. We can just run them and then trigger them.
I think it's going okay, Miraj. I mean, this is basically providing an overview of what all these pieces are about. So yeah, I think this is pretty good.
Okay. So from the Uzi part, there's nothing else. You have to create your XMLs. That code and everything shared, but the Uzi code might not have been shared over there. So I'll put the Uzi code as well as the scoop INI in the shared folder again. And all those action tags, although they are again defined on the Uzi web page, I can share it with you. But I can also share all the action tags if you want for different actions. So, but Uzi will be really helpful for you stitching up all the things. So now what we have left is the Tableau part. So tomorrow we'll look into the Tableau part. Today I don't think we have time. We have just 15 minutes left. So Tableau, I just want to give you more deeper insight rather than just brushing up the thing. I don't want to run away on that part. So let's touch the Tableau part tomorrow, and that might take 1.5 hour, 2 hours based on the questions which you will be asking up. I'll be covering up the Tableau desktop version. So there you can beautifully look into the details of the summarization which you are doing in the cluster. So practically when your data is summarized, you import the data with the help of Scoop, do the filtering and summarization with the help of big Hive or MapReduce, and those summarized tables you will be pointing onto the Tableau to visualize the data. And with the help of that visualized data, you would be looking at you will be coming up with different facts and figures about your analytics or about your data. So Tableau is one way. You can use n number of other ways, but let's look at the Tableau. Most of the other tools are also similar to that. Tableau is a licensed software. The license cost is very high. But if you want to try it, you can download the Tableau desktop, which gives you 15 days trial version, and you can try it on that. So let's talk about the Tableau tomorrow, and then I'll talk about the project, which will be on the similar fashion, where you will be importing in the data. The import part will not be daily because I don't have any server which will be printing your data daily. So the import will be one time, but after that all these things would be there. You have to process the data and come up with different facts and figures about the data based on the there it's your wish to choose different technologies for different facts and figures. So tomorrow would be our second last class, and then we'll have the next class once you would be doing up your project.
Okay.
And so when will you upload all the presentation and all the
presentation? Till now, whatever was done is uploaded. For this thing, I'll just upload it after the class in the next 5 minutes.
Okay, sure. And yesterday, last week's is also uploaded. Okay, got it.
Last week would be there, right?
Yeah, it is there. Yeah.
So upload that document that you had for.
Yes, Scoop also. Yeah. That also I'll be uploading up in the PPT itself, PPT folder. Or practically, if you that is already uploaded. If you go to the code folder, everything is there. If you open the code folder, the scoop.ini file is there inside the folder called Scoop. Only the Uzi folder might not be there. Uzi folder might not be there. But rest everything what I was talking till now would be there.
Oh, okay. So can you upload the entire code directory again one more time? That way we have the latest.
Actually, Karthik, the code directory, whenever I have to import up, I have to delete a lot of files, I have to do a lot of things. So I always try to not do that, because when I am uploading the code directory, I have to be sure everything is running up, compiling up, and each time adding some files, deleting the files for different classes. So I do not upload the whole code directory. I just upload the one which is intended for you and which is really running up and compiling up. So what I've shared with you was one of the things which I've discussed till now, and some of the things that are relevant to you. And it also contains different codes for different technologies also. Those are there except Uzi. Uzi I'll upload up over there in some time.
Okay.
But
And
if you
tomorrow meeting the same time or?
Yeah, let's meet the same time. We might be ending up later early, but let's meet up the same time.
Okay, sure.
And if everything is going good, if you want to give some feedback or comments, I request you to just give some comments or feedback on our Facebook page. I'll be sharing you the Facebook page link. If you want to give up something good or something bad, just share up your thoughts over there. If you like the things what we're doing, and if you like the sessions.
Okay.
Sure. So is there any other course that you guys offer? Like, is it?
Yeah, there are a lot of
because I see your
courses.
website. It doesn't tell you like any course.
No, if you go to the website, so this is the website, our website. There are a lot of courses which are there. Big data, so all the latest technologies you will find it over there. Big data, Hadoop admin, business analytics, data scientist, Cassandra, MongoDB, Pentao. There are a lot of courses.
Hold on. Did you guys restructure your website?
Yeah,
Because
yeah.
when I went,
Yes. Everything is
yeah,
restructured
nothing was
there.
there.
Yeah.
Looks much better now.
Yeah, everything is restructured. We have.
Yeah. Hopefully this is not internal website, right? It's external website.
No,
right?
yeah, this is design Pathshala.
I can see this.
Yeah, this is design Pathshala.
Okay.
So there are a lot of courses, and there's a new course which we're starting up. That is if you people might be interested up in the data science. So right now you are looking at a big data picture, but the other picture is doing the analytics on the data with the help of open sources. So R is an open source thing which does analytics on the data. So this thing basically helps you to do the analytics on the data with the help of clustering, k-mean, and things like that. So that is a data science course which I was showing you, which I was telling you in one of my slides also, that people do three things: either Hadoop admin, or data scientist. So now the data scientist would not be only doing the data processing, but running the different algorithms or writing the algorithms to really look into the data. So this is that R analytics, and we have another course which is a merger of both the things. Net is a little slow. So if you write some Facebook comments, those comments would be coming it over here also. What happened to net? Oh man, what happened to my internet? Hello? Hello? Hello?
Can you hear me?
Yeah,
I think Miraj is.
Hello, can you hear me?
No, he can hear, but
Uh,
I can hear you.
Yeah, we can hear you.
Okay. Okay. So there was some disconnect from my side only. So there is one more thing which we have added up is the mixture of both the things. So this is a course which is a mixture of R, Hadoop, and how to connect R and Hadoop. But there are a lot of other courses also which are coming up each day. So on the latest technology.
Miraj.
Yeah.
Since you are switching pages a lot, can you go slow? I cannot see what you are talking about.
Oh, sorry. Sorry.
Can you do that?
So what I was saying is, previously I was saying that if the data scientist, if you want to look at the data science part, so big data is one thing. The next thing is you have to write the algorithms to do the data processing. Right now we have just seen how the data processing would be done up with the help of technology called Hadoop. But you have to write your real algorithms to do the data processing. Hadoop is just a framework which help you to do the data processing. So for those algorithms, people normally use things like R because R is an open source, so R is highly used in the industry for those analytics. So this is a course which is intended on data analytics, that is business analytics with R. And this one more course which is similar to this is business analytics which includes R and Hadoop both. So this is a merger of Hadoop as well as R. This course is not only talks about the big data, but this course also talks about R and how to integrate both the things. So this course is intended for that thing, and there are a lot of other courses on the latest technologies like Spark, Scala, Mahout, iOS, Amazon, AWS. There are a lot of courses which we are adding up each day based on the demand and supply. And Hadoop
so on the Spark and Scala, what is the extent you cover? You actually so have some use cases like because Scala is something new, right? It's kind of like a scripting of like is that right? Like
so
instead of Java, you use
yeah. So Spark basically supports three technologies. One is your Python, one is your Java, and one is your Scala. So, but the Scala version is said to be faster as compared to Java due to different reasons and due to different compilation reasons which happen in the backend. So, a Spark and Scala course is basically helps you to understand Spark with the help of Scala, and Scala will be more. So all your RDDs will be written in Scala rather than in Python or Java. So Scala is so basically Spark do all the processing for you in memory. So till now we were seeing your processing were done on the corresponding nodes and your data is not loaded into the memory's whole data. But Spark does all your processing in memory, and there are other things also. So Spark is much faster as compared to native MapReduce, and Spark commands or RDDs can be written in Scala, Python or Java. This course is intended to help you understand Spark with the help of Scala, because Scala is much faster based on the compilation at the internal compilation version. How that happens, I don't know. So based on that, Spark with the help of Scala is said to be much faster. This course talks about Scala, basics of Scala and Spark, and extensive about Spark. It just covers some basics of Scala and then it talks about Spark.
Yeah, hi Miraj. Just a quick question.
Yeah.
So do we need to know anything about data warehousing concepts also as part of this big data?
Basha, actually data warehousing, it will again depend on where you are using it. You might be using Hadoop cluster to create data warehousing, but in that case, I do not see that you would be knowing the concepts of data warehousing. Only the thing which you would be knowing is the star schema and dim and fact tables. So that is sufficient for you to do the data processing and produce the different facts and figures about the data. The designing the database would similar to how your current databases are designed. For DBS design those databases, and you use those databases to insert the data or to get out the data or to maintain your transactions. The same way you would be doing over here. Your data warehouse structure might be designed by your DB only, but you have to know the star schema and the facts and dims kind of thing.
Okay. Okay. So after this course,
so in the class that
go ahead, Umesh.
No, you complete, and then I'll ask you next.
Yeah. So after this course, once we complete the project and we get a good understanding of all these various technologies, any other course do you recommend?
Basha, basically. That depends on where you want to go. So if you are looking for data science kind of thing, I would recommend to you this business analytics. The teacher of business analytics is again the great guy. He's from IT Delhi, working in analytics for last 10 years. So this course will open your insights about. So till now you have understood how to process the data, but when you apply the algorithms on the data, you you are really doing the data processing. So till now you know how the data processing is done, how to do extensive data processing, but what algorithms which you have to apply on the data to look into to get the data to get the insight of the data. So the combination of R and Hadoop what is used in the market these days is high, because most of the companies are doing analytics on the data, and this analytics is done on the big data platform. So the problem with native R is the R runs on a single node machine and loads your data on the memory and do the processing. So, but when you integrate R and Hadoop, then you'll see the real power of Hadoop with the help of and doing the analytics on the data. Or if you are looking at the admin part, you can go to the admin course also. So that will talk to you about how. So right now I shared you the pre-configured cluster, but this course will target you to how to install a cluster, create your host cluster, manage your cluster, debug your cluster, look at the logs of a cluster, and a number of things about a cluster.
Okay.
There are other things also based on interest you can target, but right now for the big data world, these are the things which are used. These are related to code.
So where does the Hadoop security come into play? Because I read something about Hadoop security is really hot in the market now.
Hadoop
is it all covered in the admin?
Admin part, yeah. So admin part talks about Kerberos. Kerberos is used for security for clusters majorly. But now with the latest version of Hortonworks, there's something called what we call that, Nox. So Nox is what Hortonworks has came up with that will also useful for securing the cluster, but natively or the vanilla version is your Kerberos, which is used for securing your Hadoop clusters. And you can define other level of security. Also, you can create groups, and on the file level security also. On Hive, you can define user permissions with the latest version of Hive. Similar to your MySQL tables, you can just say table level security on the Hive tables also. So they are the securities are different layers, but for cluster level things, Kerberos is used widely across everywhere. So Kerberos is an algorithm to maintain, checks on, not checks on basically, what call it, securing your calls, what are made in the cluster. So, if you put some of the comments.
Overall, I think I'm pretty satisfied now.
Okay, thanks for that. And if you are liking it, I would just request you to put some feedback on the Facebook page, and if you put it over there, that might come over there also. So these are our previous friends. Some of them are taught by me only. So
will you be sent?
This person was taught by me only. So some of them were taught by me only.
Sure. I think in the Facebook, is it Design Pathshala is the...
Yeah, I'll share you the link. I'll share you the link. Design Pathshala is the link, but I'll share the link.
Okay.
So just try out this Oozy part and Scoop part. They are very easy, but Oozy you might be facing some errors. So don't worry about the error. Don't hesitate by those errors. Just look into the logs. I am 101% sure you will be able to resolve them, but still I am there for you for all the help. So try out that Oozy part. Try to run one job by yourself, and I'll share this code also with you. And then let's talk about the Tableau tomorrow. And if you want to do the hands-on, now please install Tableau, download Tableau from the Tableau website. I'll share the link, and that will be only a 15-day trial. The license I can't share with you. It's very, very costly. Okay then everyone, I think thanks for time. And if you have any other questions, anything related to big data also, anything related to analytics also, anything related to R also, although I'm not great at R, but I know some of the concepts of R, anything related to Spark also, anything related to any big data world, any questions, just come up with those things. Whatever I know, I will be definitely try to help you. Sure. So let's meet tomorrow, same time, and have a nice day.
Okay. Thanks,
Bye-bye.
Mahesh.
Thank you. Bye-bye.
All right, bye.
Bye.